Yeah, before we actually do this, we need to do a little bit of review on simplifying radicals. So that's why I was hesitant to remind you. If you have the square root of 25, let's say, we all know that that comes out to be 5, right? Sure. But what happens when you try and take the square root of 75? You can simplify that radical. Rosie,
So
how?
what you would do is you would break it up into 25 and 3, and then you would take the 25, put that on the outside as 5. You find the square root of 25, which is 5. Put that on the outside of the radical and keep 3 on the inside. So it would be 25 root 3.
That would be 5.
5 root 3. Perfect. So when you simplify a radical, it's similar to like reducing a fraction. You just have to clear away any of the perfect squares, they're called, right? So if I gave you the square root of 32, you find a perfect square that goes into it, preferably the biggest one because there's more than one. 16, yeah. If you split this up into 16 and 2, that just becomes 4 root 2. A very common mistake is that kids will be like, oh, 4 goes into 32 and 4 is a perfect square. That's true, but just like reducing a fraction, if you don't reduce by the biggest number, you're going to have to do it again. So I'll just show you if you had not realized that 4 wasn't the largest, you'd get 2 root 8. Obviously, that's not the same thing, right? Because now 8 still has a perfect square factor. You're not done yet. So you have to go through it again. You would then have to say, oh, okay, well, 8 splits into 4 and 2. Don't forget this 2. I'm just going to bring that down. So you'd get 2 times the square root of 2. So you would eventually end up with the 4 root 2. But see how much more work that was? It's like if I gave you 100 over 200 as a fraction, and you didn't divide both by 100, you kept dividing by 2, right? You're doing so much more work. So what you always want to do is try and find the biggest perfect square that divides in, so you only have to do it once. And then it's simplified and you're done. You always check the thing underneath the radical sign called the, anybody remember the name for that thing?
Radicand?
Yeah, the radicand doesn't have any more perfect square factors. Okay, so let's say I gave you, oh, I don't know, square root of, okay, let's do that, 300. So think for a minute what the largest perfect square is that goes into that. Catherine?
You shouldn't say that you can't do this because it's a radicand, not a radicand.
Boy?
100.
Perfect. I can.
Captain, why'd you get that
Aw, you
I think that was a good one.
3 and 100.
Yes, 3 and 100. Same problem. You don't want to split it into 25, even though 25 goes in. It's not the biggest. So 100 and 300, you get 10 root 3. What about if I have a number out in front? So say I wanted to reduce, oh, I don't know. How about 5 root 50?
Then it would be 5 and then 25. And then it'd be 10. 25. The answer's 25.
Final answer 25?
25 or 2.
Because
25 root 2.
25 root 2, right? This 5 out in front, it's just multiplication, right? So that 5 out in the front just means 5 times, and now just handle this.
25 root 2.
So that one, yes, thank you.
Thanks, Lizzie.
25, I get a root 2, 5. That square root of 25 is 5 root 2,
Oh.
25 root 2. So that's correct. But a number out in front, guys, just remember that's multiplication. So you're just going to multiply by whatever comes out. How do you multiply two things that are in radical form? Like, how do you do square root of 6 times square root of 3, for example?
You don't. Oh, you multiply them together.
Yeah, as long as they're both under the radical, you can multiply them
Start
together.
with 18, then you do root 9, root 2.
Yes.
And that is-
Square root of 18, and now you'd have to simplify it, 9 and 2,
I love simplifying.
so you get 3 root 2. So this is just a quick recap, because you've already learned this. I just want to make sure that you remember. What happens if I want to do something like, how about the square root of 10, and then I want to square it?
Oh,
What's that come out to be?
it's just 10.
10. Why did I say 4?
I don't know. It is 10,
Why is-
right?
Literally no idea.
When you square a square root,
There, and I said it.
It
but
cancels
it's
it.
Right.
You just gotta get rid of the square root, basically. Like if
right.
the
Think
square-
about what that really is. Square root of 10 times square root of 10 is really square root of 100, but isn't square root of 100 just 10? So your shortcut is that they just cancel each other out. You just end up with a 10.
It's kind of like what's the what's,
But be careful when I have something like this. Hi, Lydia!
there you, no, you didn't. I was gonna
What if
say-
I had 6 root 3 and I squared it? Everybody do this one out for me,
Walked
please.
by and I was like, oh, she missed her. No.
So everybody give this one a try. 6 root 3 and you square the whole thing. Don't say your answer out loud. Just get it. Write it down. See what you end up with.
I kind of want to talk to her. What? Oops, I'm sorry. Okay.
Wait, is there... Wait, actually there's a video? I just said 4, and I'm an idiot.
No one knows who you are. It's okay.
Because I looked at like 4, and I was like, oh yeah, 4. And I was like, no,
Like,
it's 10. Wait, why are you doing a video like about this? This is a review.
Huh?
This is review.
I know. But just in case.
Oh my god, I'm embarrassed now.
No one knows that it's you.
Yeah.
Wait, I have a question.
Fine, I was-
No one knows that it's you,
That
Susie.
was
Don't
Caitlin
worry.
Shonak.
I hate you.
Oh. Tried to help. All right,
I know,
anyway.
literally.
When you do this, hopefully everybody did it correctly. You're going to have 6 times root 3 times another 6 times root 3, right? When you square something, that's what it means. So 6 times 6, that's fine. That's 36. And then what's square root of 3 times square root of 3?
9.
It's
3.
just no, 3.
It just ends up being 3. It's a square root of 9, which is just 3. So then 36 times 3 ends up at 108.
Nope.
108. Okay? And then just one more thing real quick that I want to go over is if you wanted to add or subtract these. So let's say you had, I don't know, 5 root 7 minus 2 root 7.
3 root 7.
Right. It's just as though the variables were, the radicals were x's. So 5x minus 2x is 3x. Right? The x's don't change. You do 5x minus 2x all the time. Same thing here. 5 root 7s minus 2 root 7s gets you 3 root 7s. What happens when they don't match? So if you had 3 root 2 plus 7 root, I don't know, 5.
Then it would just be. I don't
That's
know.
done.
That's done. You cannot add them
Same
together.
thing.
It's like 3x plus 7y. I can't go any further. That's the best I can do. So they have to be like radicals in order for you to add or subtract them. Multiplying, though, doesn't have to be. Like these two weren't like. Multiplying, same thing. X and y. You can multiply x and y together. You just get x, y. So these two, even though they're different, you can multiply them together, but you cannot add or subtract them. Adding or subtracting, you have to have like radicals. Okay? Real quick, let's just talk about dividing, even though I don't think we'll be doing too much of that, but you never know. How do I do the square root of 6 divided by the square root of 3? Clyde, go ahead.
You have to first multiply each by themselves.
No, you don't.
You can, but if they have a common factor,
Why?
guys, listen, this is the same thing. You can, if both your numerator and denominator are under a square root, you can make it one big square root for 6/3.
Just to,
And 6/3 is just 2, so you just get the square root of 2. But if they don't match, then we have an issue. So if there is no common factor, have a common factor. So if you had like square root of 3 over the square root of 5, right? I can't just reduce, right? It doesn't just reduce to be some nice number. So this is where we do what Clyde says. So I'm going to multiply by what, Clyde?
By square root of 3, square root of 5.
5, 3.
You can't multiply by that.
Wait, is it by the denominator?
By the denominator. So it's square root of 5 over square root of 5. Now hold on. What is square root of 5 over square root of 5 really? 1. You can multiply a number by 1 and it doesn't change its value. That's why you're allowed to do this. So now if I just multiply straight across, on my numerator I'm going to get square root of 15. And the denominator, what do I get though? Just 5. This is called rationalizing the denominator. You are not allowed to leave radicals in your denominator. You always have to move them out. You can leave them in the numerator, but you cannot have a square root in the denominator. Yeah.
So like, I'm sorry. So how did we decide on multiplying it by the square root of 5?
Because that's the denominator.
So it always has to be the denominator?
Yeah, you always multiply it by the denominator over the denominator, because that's just 1, so you're not changing the value of the fraction.
Okay.
A very common mistake, which none of you will ever make, I'm sure, is to take this and just square it. Kids are just like, oh, just square it. You can't just take a number and just square it because you want to. You could take an equation and square both sides, but I can't just take something and square it. I can't take the money in my bank account and just square it. Imagine if I just, great question.
You can, it's just that's a federal crime.
Well, I can't walk into the bank and say, oh, I'd like to just square it. But what I could do is I could exchange my money. I could say, I have a $20 bill, can you give me 20 singles? Right? That's an even exchange. This is an even exchange because all I did was multiply by 1. Right? So I can exchange my currency, but I can't just square it, or I can't just multiply by 2, or you can't just do these things, right? Because it's an expression, not an equation. Equation, I can do whatever I want as long as I do it to both sides. Right?
Yes.
Expressions, there's not much I can do with them. I can simplify them and I can multiply them by 1. Those are really my only options. Okay? So that's it for our review of radicals. Now we're going to use these skills to talk Pythagorean theorem. Stay tuned.